right, guys, Steve Stratton here, Redline Emissions Products. Today we are looking at the Filtertherm Inspection Table / cart. So in the DPF cleaning industry, we need to know a few things. During the cleaning process, we need to know what does the filter weigh, number one. Number two, what is the restriction? What is the flow reading? Number three, are there any visible cracks? We're going to use a light detection for that. And then number four, does it have hard ash centering? Does it have hard packing? What's inside the filter? We're going to use the wire test for that, or pin drop test, some people call it. Filtertherm's inspection table puts all that in one package. We have an auto-calibrating scale, a digital display. We have the flow chamber, which operates on the industry standard flow rates. And we have conveniently located the wire test rods for the pin drop, all in one small, compact package. So let's get started. When we power it on, our machine is touchscreen. The backsplash is going to load, and it's automatically going to calibrate the scale, the filter onto the machine, record the weight. Switching from flow to weight is very simple. Simply tab the flow button. It changes and shows us a flow restriction reading, and it gives us our fan icon and our light icon. The fan icon is for flow restriction, reading the flow rates. The light icon is for reading the crack detection. The light is inside the flow chamber, so what we will do is place the filter over the open port of the flow chamber, press that light button, do our light detection test. Once we've done our light detection test, we've determined that that filter is not cracked, or it is cracked. If it is, replace it. If it is not, move on to the flow test. All right, so what we're going to do now is I'm going to walk you through the inspection table's process, how we use it, and what we do like step by step, starting from weighing the filter, wire test, light detection, and then flow test. Let me grab a filter. So first thing we're going to do is set the filter on the table. We need to know the inlet from the outlet of the DPF. To determine that, number one, the inlet should always be dirty, the outlet should always be clean. If the outlet is dirty, something's not quite right, soot's bypassing the filter somewhere, now we need to figure out where. This particular filter, the outlet is clean, the inlet is dirty, so it's not visibly internally compromised. We're still going to do a light detection test, but for now, we're going to assume that the brick is not damaged based on the outlet. We know it's the outlet because the orientation. Most filters either have an arrow or they have sensor fittings, sensor bungs. Most sensor bungs are labeled temperature 1, temperature 2, temperature 3, and temperature 4. If you have a DPF with an inlet, DPF inlet temp sensor on the inlet of the DPF, it should be labeled temp 2. If it has an outlet temperature sensor, it should be labeled temperature 3, and this particular model is labeled that way. So what we're going to do first is we're going to weigh the filter. We're going to do that. We'll power on our machine. We're going to let our scale calibrate, and we're going to read the weight. The weight's in grams. We record that weight so we can see the before and after weight rating of the DPF, so we can see how much ash was removed from the DPF. Ash is comprised of lube oil and fuel additives, so we want to know, is it excess fuel additives or is it lube oil? We can ask our customers, is it burning oil or is it just a fuel additive? Once we've recorded our weight, we're going to take our wire test rod. We use 030 stainless TIG rod, and this is, some manufacturers call it a pin drop test, but what we do first is we insert the rod down into the outlet side of the filter. When we put the rod into the outlet side of the filter, it's going to tell us how deep our brick is, what dimensions. Once we know that, we have a gauge for the inlet side. So we know our wire travels into the filter this far, that's the bottom. The outlet side of the filter should always be unrestricted, so we'll bend this wire test rod, and that's going to give us our gauge. Now we've got our gauge, we'll take the filter and flip it over. Flip the filter over, it should be the dirty side of the filter. We will insert the wire into the filter in roughly 20-30 cells. If you find a cell in the filter that is restricted or it's got excess buildup, hard ash centering, You want to work around that cell and determine how much is actually in there that's restricted, okay? And we'll do that like this. Wire testing the filter is going to tell us if it has hard packing. Hard ash centering is very difficult to remove from a DPF. So what we want to do is see how much hard ash centering is in the filter. In this particular filter, from what I found so far, it does have hard ash centering and it is 1/3 restricted. Our recommendation is if the filter's flow efficiency is restricted by more than 1/3, we recommend replacing that filter. The reason we recommend replacing the filter is because of the flow efficiency. If you decrease the engine's ability to flow exhaust, you're going to increase back pressure, you're going to increase fuel consumption, you're going to see lots of forced regens, and that's something we just don't want. When you're doing the wire test, there's really 3 feelings you're going to find. One is hard crunchy. That's hard ash centering or hard packing. That's where the ash in the DPF melts and sticks to the substrate's cell wall. That's hard packing. It's either hard packed or it's actually melted internally. If it's melted internally, you should see soot on the outlet side. If it's not melted and it's just hard ash centering, you should have a clean outlet and a dirty inlet. A good rule of thumb is if it's smoking, it's broken. So we've already determined this particular filter is 1/3 restricted. When we wire test it and it stops, we take our second measurement, pull it out, and we measure across the brick. If we were to cut this brick into thirds, we would see that it is 1/3 restricted in most areas across this filter. So this filter is a candidate to be replaced. So now that we've wire tested the filter, now we're going to use the light detection or the crack detection test on the filter. We're going to flip the filter over and place it on top of the flow chamber. Once the filter is placed on top of the flow chamber, tab or toggle to the light detection tab, turn on the light, and take a look. When you're looking into the filter, you should not be able to see through the brick. If you can see through the brick, then you have a bypassing filter. It's either melted or it's actually cracked. If you see light through more than 20 cells, this filter is bad. It needs to be replaced. We'll do a flow test with the filter sitting just where it's at. We will turn on the flow reading. We're going to take that reading and we're going to compare it to the Filtertherm flow chart. It should be within spec. This particular model of DPF its flow rate should be right around 2.1 to 2.2 inches of water. So we'll flow test it and see where it's at. The flow rate on this filter here is actually 2.5 inches of water, which means it's outside of its spec. So we found a few things in the process. We found it has hard ash centering in our first step of our process, and it was more than 1/3, which deemed it failed and needing to be replaced. We did a light test or crack detection test, and we found cracks. And then we did our flow test. Our flow test tells us that the filter is restricted, which coincides with the hard ash centering, which means this filter is in fact restricted, it's compromised, and it is due to be replaced. All of that from a few minutes at a table is fairly straightforward, and it's fast and efficient.